Good morning, everybody. Welcome to our online maths class. I like to start our class with a few examples. Children, how do you count the books of your own school bag? Same way, how do we count the fingers what I am showing to you? Yeah, you know how to count it by using numbers. Number 1, 2, 3, 4. Come on. How many fingers are showing to you? Is it 10 fingers? Yes. That is, we are discussing about numbers. Now, we have counted our fingers. Same way, you are able to count the number of books of your school bag, and we can count the number of students who have seated on your bench, and we can count many other things. All these are possible only by counting the numbers. So all these are called counting numbers. Counting numbers also called as natural numbers, isn't it? So natural numbers are denoted by the letter, capital letter N. So natural numbers are denoted by the capital letter N and started from 1, 2, 3, 4 and goes on infinitely. So these are called natural numbers. We know the usage of these natural numbers. Just now we have seen these are used for counting. And whenever you have some money in the hand, you say, I have 5 rupees in my pocket, or I have 10 rupees in my pouch. Same way, a boy or a girl was there and there is no money with them. Can you expect the answer from them by using these numbers? Yes, there is a symbol or the digit called 0 we can use to express a person who don't have money with him or her. A person with no money can be expressed as 0 rupees are there with them or with him. It shows that the usage of 0 also needed for our life. Then we will come to know a new number set called whole number set that are with 0 and natural numbers. Whole numbers are numbers which are mixed with 0 and natural numbers. Now we can see natural numbers are starting from 1, whereas whole numbers are starting from 0. And natural numbers will not have its greatest value. That says that the greatest value cannot be obtained. Same way, the largest or the greatest value in the whole numbers cannot be obtained. Infinitely we can extend that. So we can say only smallest whole number as 0. Same way smallest natural number as 1. Now we are coming to another example. Whenever we have money, we can express with natural numbers or we can count with our natural numbers. But when we don't have anything in our hand, in the case of counting money, we can express we have 0 rupees or no money can be informed. But there are certain examples we have to express some views. That is, suppose there is a loss took place in any of the business or any of the place. 100 rupees loss took place. That can be expressed with minus 100. Minus 100, that is 100 rupees loss. Now negative numbers are needed for our life. So negative numbers along with 0 and these positive numbers, we will have another set of numbers called set of integers. That is only our today's lesson. That is the topic with which we are going to discuss. So set of integers is our lesson. Now we will discuss about integers. So here integers are denoted with capital letter I. Capital letter I called integers. This set is having negative numbers, again positive numbers, and there is one more digit called 0, which is neither positive nor negative. It is simply an integer. It is a neutral integer. So finally we can say about integers. As for the definition of the integers, integers is a set which is the combination of positive integers and 0 again with negative integers. So these are the negative integers, these are the negative numbers, positive numbers, and there is a digit 0 which is neither positive nor negative. So all the numbers together called set of integers. Now natural numbers are used only when we want to express something for the counting and all those, but whole numbers are expressed along with natural numbers and 0. Now set of integers are having negative numbers with 0 and positive numbers. So now we are coming to the product of the integers. Whenever we multiply two or more integers with their respective signs, what is going to take place? We will discuss about that. Suppose this is a positive integer plus VE is a positive integer. It is going to be multiplied with another positive integer. A positive integer going to multiply with another positive integer. Then we will get a new integer that is also with a positive sign. So for example 5 is with a positive symbol and 6 is also with a positive symbol. 5 into 6 is 30, which is also with a positive sign or symbol. Now from this we can say two positives, when numbers with two positive symbols, when they multiply each other, we will get a new number called, that is also an integer, but that is with a positive sign. Now coming to the another set of the product with their symbols. Let us take a positive integer and a negative integer in the second place. If at all we multiply two integers with positive sign and a negative sign, as I have shown just now, then the result will be a negative integer. For example, then this is 3 with a plus symbol, that is positive integer, and a negative integer is minus 2. Then 3 into minus 2 will be equal to minus 6, which is called a negative integer. Now coming to the third type of the multiplication with different symbols. Now let us take both negative symbols with the integers, both negative ones. If at all two integers are multiplied with negative symbols called minus symbols, then we will get an answer that is an integer with a positive symbol. For example, minus 4, if you multiply with minus 6, 6 there is 24, then minus into minus is becoming plus 24, that is positive integer. Now one more multiplication which we can do is the fourth multiplication. Here it is both negatives are multiplied, and here it is one positive and one negative. Here is both positives are multiplied. Finally first one is negative multiplied with a positive integer, then the result is always a negative integer. For this example is -5. If you multiply with +7, then the result is -35. That is called a negative integer. By these examples, we can conclude that if at all two positive symbols are multiplied, the result will be positive integer only. Then, if two integers with two negative symbols were multiplied, the result will be again positive only. That means whenever two numbers with two positive symbols multiplied, the result will be a positive integer. If two negative symbols were multiplied with the integers, then the result will be a positive integer with the plus symbol. And another set, if at all two different symbols are multiplied, two different symbols means the integers with different symbols. An integer with a plus symbol and another integer with a minus symbol. If at all we multiply them, always the result is negative. That is, first one may be a negative integer or second one may be a negative integer, but always result will take place only negative integer. This is about the product of different integers and their respective symbols. Now we are going to discuss about the multiplicative properties of integers. Multiplicative properties of integers. So properties of integers only based on multiplication. There are some properties for us which we need to learn about it, because by using the properties only we are able to multiply the integers, and we will see that part of it. Now, first and foremost property for integers properties of integers. With respect to multiplication, so that is we are going to do the operation with the multiplicative symbol called multiplication. That is only we will get product. Now let us take a first property named closure property. Closure property of integers for multiplication. Closure property. According to the property, that is closure property, for any two integers called a comma b, take any two integers called a comma b, then a into b will give you a new integer called ab, which is also an integer. This is called closure property of integers under multiplication. Now, I repeat it. Let us take any integer. Suppose 5 is an integer. Same way, b, it may be 4 is another integer. Then 5 comma 4 are both integers. Then when we go and multiply 5 and 4, 5 into 4 gives you a new integer called 20. This 20 also there in the set of integers. So the set of integers are satisfying the closure property with respect to the multiplication. Then we'll go for the second property, commutative property. Commutative property. The commutative property says that for any two numbers or two integers a comma b, then what happens? A into b will be equal to b into a. That whenever you take a as a 3 and b as a suppose 5, then a into b, 3 into 5 will be equal to then 5 into 3. So 3 5s 15 will be equal to 5 3s are 15. So the order only changed. A is taken as a first place, B is written in the second place. But whereas in this side, B is written in the first place and A is written in the second place, the results are same. According to the property called commutative property, the A into B result will be equal to the B into A. That is commutative property. From this we can say integers are satisfying the commutative property with respect to the multiplication. Then third property, associative property. Associative property. So according to the property written here, that is associative property, for any three integers a comma b comma c, when you multiply a into b into c is equal to a into b into c. You take any three integers named a, b, c, like 2, 6 and 8, then 2 into 6 into 8 will be equal to 2 into 6 into 8. Now you see 2, okay, 6, 8s are 48. 48 into 2 will be 96. The answer is 96. That will be equal to 2 6s are 12. 12 with 8s 96. So 96 is equal to 96. From this we can say set of integers are satisfying the associative property with respect to multiplication. Next, fourth property of the integers, distributive property. Distributive property is the same. It is as the name is containing the word distributive in it, so it distributes the one of the number with the other numbers given in that. Let us see that. Take a comma b comma c are any three integers, then a into b plus c, a into b plus c is equal to a into b plus a into c. Here multiplication distributes over addition. This is called distributive property of integers. Integers are satisfying the distributive property. Here multiplication, a is multiplying with the b plus c. So a is only distributing, that is called multiplication distributes over addition. Here a into b minus c is equal to a into b minus a into c. This is also true for the distributive property of integers. It is multiplication is distributed over subtraction for the integers. The next property is identity property, existence of identity. Existence of identity. Existence of identity. Suppose existence of identity is, that is multiplicative identity. For multiplication, existence of identity for multiplication. Suppose take any integer a, and when we multiply that integer with 1, again we will get the same integer what is taken. So here 1 is called multiplicative identity. This one is called multiplicative identity. Multiplicative identity. So whatever the integer you take and multiply with 1, you will get the same integer as our answer. Then the 1 is called as a multiplicative identity. Now, sixth property, which is existence of inverse. Existence of inverse. Existence of inverse for the multiplication. Suppose there is an integer a and there will be another integer named 1 by a, so that a into 1 by a will be equal to 1. Then we say 1 by a is the multiplicative inverse for a. Same way, a is the multiplicative inverse for 1 by a. For example, take 1 as an integer, and the same for this multiplicative inverse is 1 by 1. 1 into 1 by 1 gives you 1. Same way, 1 into minus 1 into 1 by minus 1 gives you again 1 only. Then here minus 1 is a multiplicative inverse for itself. Same way, plus 1 also multiplicative inverse for itself. So we need to understand all the properties which are related to the integers. These are needed for us. When we multiply the integers, we will use them. There is a last part which we need to discuss in the, that is product of an odd number of negative numbers and product of an even number of integers. That we are going to discuss. Let us see once. Suppose here odd number of negative integers.